if you're interested, you can read all this stuff right here. Okay, I think it's some pretty interesting stuff about orbital mechanics. I studied that quite a bit in school, but really what this question is just asking you to do is a little algebra. It wants you to rewrite the equation that's given to you and solve for the variable m. Now, there's all sorts of reasons you would want to do this. One thing you can do if you're studying celestial objects, say some kind of an asteroid swings by a planet, and it swings by at a certain speed. Well, based on how fast it's going around the planet, you can try to make an estimation on how massive that object, that asteroid is. It's kind of cool. But let's just rearrange this in terms of the variable m. So I want m by itself. Let's start out with t. T equals 2 pi times the square root of r cubed over gm. So I'm gradually going to peel things away from that m. First thing I'm going to do is divide both sides by 2 pi. So I get t over 2 pi equals the square root of r cubed over gm. And now what I'm going to do is square both sides. Okay, that gets rid of the square root on the right. And I just have this. T over 2 pi squared equals r cubed over gm. Well, let's multiply. Let's distribute this exponent. Okay, it'll be a little easier to talk about that way. I'm going to have t squared over 4 pi squared equals r cubed over gm. And I'm pretty close to getting m by itself, actually. I'm just going to multiply both sides by m. So you get a little times m here, a little times m there. Those cross out. And now I have this, m times a whole bunch of stuff. Well, let's keep on working on this. Let's multiply each side by 4 pi squared. I'll clean it up after this step, but you can see that the 4 pi squared over here is going to cancel out with the bottom. So now I have mt squared equals 4 pi squared r cubed over g. And now all I have to do is divide each side by t squared. And I have the following. M equals 4 pi squared r cubed over g t squared. That's my equation in terms of m. Now, there's a whole bunch of varieties of this problem. You may have the version of it that talks about orbital period between 2 point masses in space. You may have a version of this that talks about a particle's position as a function of time. You may have equations, there's all sorts of equations in physics. And frequently, people will want to talk about one variable that's tucked like right in the middle of it, and they want to describe that variable alone. That's what this is about, the algebra of handling equations.